In this video, we demonstrate how standard protocols enable the automatic installation and operation of sensors in an IP network. Several steps must be performed to install and use sensors within a network. An IP address at which to access the sensors must be assigned. This usually requires a DHCP server on the network, or it is done manually. A human-friendly name must be associated with the address so that users may easily find the sensors on the network. A domain name service is usually required to distribute this name. The sensor's address, host name, and IP port number must somehow be advertised to client software and human users. Driver software that speaks the sensor's protocol must be installed so that sensor data can be acquired, parsed, and processed. Software to display the data, often in real time, must be provided. In this demonstration, we show how these steps can be automated using established and proposed standard protocols. For this demonstration, we've implemented these protocols on the Texas Instruments Luminary Development Board, which we call the IP PUC board. The board acts as a gateway between the network and an RS-232 instrument attached to the board's serial port. Protocols execute on the board's Stellaris microcontroller. Metadata can be stored on the microSD card. Status messages can be displayed on the LCD diagnostic panel. In addition to the IP PUC board, demo hardware components include a commercial RBR data logger with conductivity, temperature, and pressure sensors connected to the board's serial port. Note that this instrument itself doesn't implement any standard protocols. Instead, it's operated by a manufacturer-defined command protocol through the serial port. The laptop on the left is connected to the IP PUC board through an Ethernet switch. PUC protocol was originally developed at MBARI and is a proposed Open Geospatial Consortium standard. PUC-compliant devices provide standard metadata about themselves. Additional information can be retrieved from the device's so-called PUC payload. A PUC service that runs on the IP PUC board can be accessed by clients on the network. ZeroConf is an industry standard that enables the IP PUC to automatically get an IP address and host name without the use of DHCP or DNS, and to advertise its PUC service's address, name, and IP port number on the network, allowing users to easily discover and use it. SensorML is an Open Geospatial Consortium standard markup language that describes sensor data formats, command protocols, and other sensor characteristics. In this demonstration, a SensorML document that describes the RBR instrument is stored in the IP PUC payload and can be retrieved by network clients via PUC protocol. The laptop hosts a browser that allows users to discover ZeroConf services on the network, including the PUC service. When the user selects a PUC service in the browser, the PUC reader will retrieve the SensorML document from the IP PUC board. The SensorML is then interpreted by a universal instrument driver, which uses the manufacturer-defined protocol and format descriptions to acquire data from the instrument and to parse the data into separate channels. This universal driver can operate any instrument whose data format and command protocol can be described with SensorML. The universal driver passes the parsed data to Data Turbine, which is an open-source toolkit for reliable data acquisition and display. First, we apply power to the IP PUC board, which then will automatically join the network and advertise its PUC service using ZeroConf protocol. ZeroConf can do this without a DHCP or DNS on the network. The IP PUC service now appears on the laptop's ZeroConf browser. The user selects the service, which causes the PUC reader to retrieve the RBR SensorML document from the IP PUC board and display it. The SensorML describes the RBR instrument, sensor characteristics, and protocol in a standard way. The PUC reader registers this information with Data Turbine, and it automatically appears in the real-time data viewer, as shown here. The universal instrument driver then acquires data from the RBR and parses it into conductivity, temperature, and pressure values, which it writes to Data Turbine's ring buffer. These values are displayed by the real-time data viewer as they are acquired. With these protocols, we've automatically installed and operated a commercial instrument that itself does not implement a standard command protocol or data format, with no required manual steps beyond applying power and selecting a service in a browser. This approach will work with any instrument whose data and protocol can be described with SensorML. Just plug it in and it works. This is Tom O'Reilly at the Monterey Bay Aquarium Research Institute.